In the previous videos, we discussed the questions based on the properties of determinants. And today's class, I continue the questions. So now, my dear students, the next question here I wrote on the board, that is, prove that the given determinant is like this. This determinant is equals to a minus b into b minus a into c minus a. And this question was asked in June 2017 Karnataka Board examinations. In annual examinations, they asked these questions. Very important such type of questions. So and very easy also. My dear students, just observe the questions. In mathematics, whenever they given to you a question, first please try to read the question. After reading the question, before using the pen, before solving the question, first you should think in your mind that what should I do? Clear? To solve this question, what should I do? You should think in your mind before calculating this, before writing, before using the pen. In mind, once you should think what should I do for this problem. Clear? Yes. So I told to you that whenever we have the elements 1 1 1 in the row, either in the row or in the column, if you have the elements 1 1 1, then try to make those elements as 0. So those elements we should try to make 0 because you can expand easily. So if these two elements, if I make 0 means along the column, if you expand means the calculations will be easier for you. For that purpose, whenever you have the elements 1 1 1 in the either in the row or in the column, if you have means first you should think that how to make these elements 0. That is the first thing that should be come in your mind. Clear? And another one thing is here a minus, you should not expand only, you should show that, or you should prove that the determinant of this is equals to a minus b into b minus a into c minus a. That is also very important. You should keep in mind that what should I prove here. You should keep those two things whenever you are solving such kind of questions. You should think two things you should prove, or you should think. That is first thing is how to make the elements 0. That is the one thing. And another one thing is what should I prove. These are the two things you should keep in mind. Clear? For that, first see here my distance. What I do here, either row 2 may changes row 2 minus row 1. If I apply the operation row 2 changes to row 2 minus row 1, then this element will become 0. And next row 3 minus row 1, if I made that operation means this element will become 0. Clear? So that's why what I do, I apply the operation row 2 minus row 1. If I apply, that is also fine. But what I do here, I require a minus b. So a minus b is obtained. I'll obtain the a minus b if I apply the operation, that is r1 changes to here r1 changes to r1 minus r2. If you apply this result, what happens here? This a minus b, here this element is this element becomes 0. So r1 changes to r1 minus r2. 1 minus 1, this place element will become 0. And next a minus b, so this also will get. So there, that purpose what I do, I apply the operation r1 changes to r1 minus r2. And another one operation I will apply, that is here r2 changes to r2 minus r3, because here also 1 minus 1, this place element will become 0 and you will get b minus c in this place. So therefore r2 changes r2 minus r3. Clear? And now apply this operation, so you will get, here it is 1 minus 1 is 0, a minus b, a square minus b square. r1 changes to r1 minus r2. So this element minus this element 0, a minus b, a square minus b square. Next r2 is changing. How r2 is changing? r2 is changing r2 minus r3. This element minus this element. 1 minus 1, here it is 0. This element minus this element, that is b minus c. And next my dear students, here it is b square minus c square. And next third row is as it is. Only R1 and R2 change. The remaining elements of the third row will same as it is, c square here. Clear? And now this further I will write here. Here it is 0, a minus b. Next my dear students, here it is a square minus b square is there. A square minus b square, can I write it as a plus b into a minus b? I can write because we have the formula. So what is the formula I have? The formula is like this. A square minus b square can be written as a plus b into a minus b. This is the formula we have. Clear? That formula applied. A square minus b square can be written as a plus b into a minus b. I am using this formula because a minus b is here and here also a minus b. If I express this also in the form of a minus b, then easily I can take common from the row 1 a minus b. I can take the common. For that purpose I am writing this a square minus b square as a plus b into a minus b. That too by applying this formula. Clear? And next my students, 0 as it is. Next here it is b minus c and b square minus c square. The same formula I am applying here. This b square minus c square can be written as b plus c into b minus c. And next these remaining elements I write as this 1c square. Clear? What should I prove? I should prove that a minus b into b minus c into c minus c. So to prove this mentions, I will take from the first row I will take a minus b. Here also a minus, it is 0, it is this one a minus b, and here also a minus b is there. I can take a minus b common. Here b minus c is there. From these two also I can take the b minus c common. So therefore I will write here this taking common a minus b and here it is b minus c. A minus b and b minus c taking common from row 1 and row 2 respectively. We should take the common respectively. Taking common a minus b and b minus c from row 1 and row 2 respectively, we get. So what we get? So here my students, here it is from this I am taking a minus b to common. So 0. So there is no any element remaining, only 0 remaining. So write 0. From this if I take a minus b, so whatever you will take the common, that you should write outside this determinant. Clear? So what is that? This is equals to a minus b into b minus c. So from this I take the a minus b common. Here it is 0. Here a minus b common taken means only 1 is remaining, and here it is a plus b is remaining. From this also 0 b minus c I am taking common, 1 is remaining, and from this b plus c, and remaining third row elements as it is 1c square. Clear? And next my dear students, further here it is a minus b as it is, right? A minus b as it is, b minus c as it is. Now you should show that here it is c minus a. Clear? So to prove this, and what I will do, I will expand, simply expand this one. So expanding along column 1. So I will expand along column 1 because already these two elements are 0. Only I should calculate this part. Clear? So therefore I am expanding along column 1. So before expanding column 1, we should first change the sign. Is it? So therefore plus minus plus minus plus minus plus minus plus. Clear? So now expanding here, I will get. I will write here it is. So 0 into 0, 0 into anything is 0, 0 into anything is 0. Leave these two part, only take this one. Plus 1 into. So here it is 1 into leave this row and this column and this row. So what is remaining? B plus C into 1. B plus C minus of 1 into A plus B. So 1 into A plus B is, here it is, leave this row and this column. 1 into B plus C is B plus C minus 1 in minus of this element into this element. So minus of A plus B. So further simplify this, you will get A minus B, B minus C. Next here this 1 and anything is this element only. So therefore B plus C minus A plus minus B. Plus B minus B got cancels. So therefore A minus B into B minus C into, here it is, C minus A. So therefore here A minus B into B minus C into C minus A. This is what your required RHS. Clear? So like this you should solve. So very important, my dear friends. This question already they asked in June 2017. So like this you should solve. Clear? Yes, I think no need to explain in Kannada. So just simplification is there. So next I will move to the next question. I will write that one. The next question I will write. The next question, my dear friends, I wrote here, that is show that, or you can take it as prove that this determinant is equals to 0. To prove this, again you can observe here it is A minus B is there, here plus B minus C is there, here C minus A is there. It means if you add all this, if row 1 changes to row 1 plus row 2 plus row 3, if you add all these terms, everything will cancel and you will get 0. So therefore I am applying that operation. The operations I am applying here, my dear friends. Row 1 changes to row 1 plus row 2 plus row 3. I am applying these operations. If you apply these operations, this will gives you here row 1 changes to row 1 plus row 2 plus row 3. It means this element, this element, this element we should add. So therefore A minus B plus of B minus C. Next here it is plus of C minus A. Clear? And next here this element. So B minus C plus of C minus A plus of A minus B. Clear? And next this C minus A plus of A minus B. Next here it is plus of B minus C. C minus A plus A minus B plus B minus C. Row 1 is changing, row 1 plus row 2 plus row 3. And remaining elements as it is B minus C, C minus A. Next C minus A minus B. And next A minus B, B minus C. Clear? This is the determinant. Now further simplify this, my dear friends. You will get here A, here it is. You will get here A minus B plus B plus minus C. Just I am opening the bracket. Plus C plus minus A. Clear? And here also B minus C plus C plus minus A plus minus B. Just I am opening the bracket. Next C minus A plus minus B. Here it is plus B plus minus C. And remaining elements add this B minus C minus A minus B. And next C minus A minus B minus C. Now my dear friends, you can observe here plus A minus C cancels, plus B minus B cancels, plus C minus C what cancels, plus B minus B, plus A minus A, plus C minus C. Next plus C minus C minus A plus A minus B plus B. Everything is got cancels and ultimately you got the values as 0. Here is B minus C, C minus A. And next here also 0, C minus A, A minus B, and next here also 0, A minus B, B minus C. My dear students, I hope you understood. Just to the row 1 elements I added row 1 plus row 2 plus row 3. Row 1, row 2, row 3 elements I added here. That is further simplified here. So if you simplify further means this element 0, this is 0, this is 0, 0, 0 I wrote, and remaining elements B minus A as it is, C minus A as it is, A minus B as it is, C minus A minus B, B minus C. Row 1 and row 2 elements I wrote as it is. Now this determinant value is equals to 0. This is what your RHS. They told that this determinant value is equals to 0. That I showed here. Clear? And now this determinant value is equals to 0 because again I told you that one note, that is whenever in the determinant, if any rows or any columns of all elements are 0, then that determinant is equals to 0. This is the one property we have. Either you can use that property, or if you expand along row 1, if you expand along row 1, all elements are 0, 0 and anything is 0, so therefore here it is 0. So here you can write by property, like this you can write, or you can write expanding along row 1 we get 0. Like this reason you can write. Clear? So therefore this determinant value is 0. So like this you can calculate my additions. This is a simple question. Just to understand you clearly, that therefore I expanded this. Otherwise in your mind only you can write like this. After writing this step, here only you can cancel. But while opening the bracket you may have confusions. You may get confusions. Therefore I expanded here. Clear? Next we will move to the next questions that we will discuss in the next video. Thank you.